Come back. I don't think I'll introduce myself. By now you should know me. If not, please go back to the previous video. I have introduced myself. Except that I am a teacher of maths. I've taught for a long time. My name is Sosale Mohana. There I have introduced myself without meaning to. Doesn't matter. I now on to number 3. Remember I started with A. I have reached up to N. So now I got various methods of integration. Find integral x over 4 minus x the whole square dx using part A, partial fractions. Part B, the substitution u equal to 4 minus x. Yeah, let's do them. So let's do partial fractions. X over 4 minus x the whole squared equal to, look, it's a whole square, so one fraction with 4 minus x, another fraction with 4 minus x the whole square. So that's A, that's B. Multiply throughout by 4 minus x the whole squared. So I get x equal to A times 4 minus x plus B. Put x equal to 4, B equals 4. Put x equal to 0, 4a plus b equals 0, 4a plus 4 equal to 0, so a is minus 1. So it's minus 1 over 4 minus x plus 4 over 4 minus x the whole square. Right? Can I wrap this off? Okay. So therefore, stupid. So it's minus 1 over 4 minus x plus 4 over 4 minus x the whole square. So I'm still doing part A. Integral minus 1 over 4 minus x plus 4 integral 1 over 4 minus x the whole square dx. When you differentiate this, 4 minus x, you get minus 1. So numerator is exact derivative of denominator. So minus ln 4 minus x plus, please don't say 4 minus x, 1 over x gives you ln x, so 1 over x squared gives you ln x squared. Maths is my grandfather's property. No. Only 1 over x gives ln x. So can I write this as 4 integral 4 minus x power minus 2 dx? When you differentiate 4 minus x, I get minus 1. So this is like x power minus 2. So can I write this as 4 minus x minus 4 integral 4 minus x power minus 2 times minus 1 dx. So this is u power minus 2 du. U power minus 1 over minus 1. So minus 4 times 4 minus x power minus 1 over minus 1. So the final answer is ln 4 minus x. Minus and minus becomes plus 4 over 4 minus x plus c. Yeah, that's a lovely question on use of partial fractions. Very good. Now, let's look at the part B. He says, use the substitution. When substitution is given, you have to use it. So, u equals 4 minus x. Du by dx equals minus 1. So, dx equals minus du. So, it becomes integral x is 4 minus u. 4 minus u over u squared times minus du. Or integral u minus 4 over u squared du. Which integral 1 over u minus 4 u power minus 2 du. Which is ln u minus 4 u power minus 1 over minus 1, which is ln u plus 4 over u, which is ln 4 minus x plus 4 over 4 minus x plus c. So either way, but for a difference in a constant, the answer should be the same. Of course, sometimes when you do trigonometry, they become identities. Then you will be able to prove one identity is the other. Look, in 5 minutes, I could get a sip of water. That's how hot it is. And it is still early March. Right. So I've done O. Okay. Let's go to P. Bum ba bum. Integral x squared e power 2x dx. Can't integrate directly, can't use substitution, but the moment you see two different functions that are not related to each other, 99 out of 100, it's integration by parts. So, L, I, A, T, E, C. I'll keep the I. So, I have an algebraic function and I have an exponential function. Algebraic comes first, so u equals x squared. Exponential comes next, dv by dx equals e power 2x. du by dx equal to 2x. v equal to half e power 2x. So it is uv, so question equals u v minus integral v du by dx. So it is half x squared e power 2x minus integral x e power 2x dx. Again there are two functions, again integration by parts. L, I, A, T, E, C. Algebraic and that. So u equal to x, du by dx equal to 1, dv by dx equal to e power 2x. So v equal to half e power 2x. So it is half x squared e power 2x minus x times half e power 2x minus integral half e power 2x dx. So which is half x squared e power 2x, keeps on going, yeah, boring, minus half x e power 2x plus a half, and the integration gives you another half, quarter e power 2x. So the answer is quarter e power 2x times 2x squared minus 2x plus 1 plus c. You keep on doing, in fact you can close your eyes and keep on doing it. Yeah. Okay, that's another integration by parts out of the way. Now I'm doing Q. Q is integral sine 7x cos, no, sine 6x cos 3x dx. Just that. Oh, let me make it 2. Can't integrate directly, can't use substitution, can't use fractions, trigonometry. You have of the type sin A cos B. When do you come across sin A cos B? When you have a formula for sin of A plus B or a formula for sin of A minus B. I don't know which, so write both. If you can remember the formula, please go ahead. But I am banking, or I am basing on I'm making an assumption that you are not one of those people, you're like me, can't remember 10,000 formulae. You would rather derive them. So therefore, since I see sine first, cos next, I know sine of A plus B is sine A cos B plus cos A sin B. This I know is in the formula book. I don't have to remember. Even this is in the formula book. I don't have to remember. I prefer this way than trying to remember 10,000 formulae. What happens when you add them? I get 2 sine A cos B equals sine of A plus B plus sine of A minus B. So I have 2 sine 6x cos 3x is equal to sine of 9x plus sine of 3x. So it becomes integral sine 9x plus sine 3x dx. When you integrate sine 9x, I get minus cos 9x over 9 minus cos 3x over 3 plus c. So I don't remember the formula, but the moment I have a sine of one angle and a cos of some other angle, I prefer using sine of A plus B and sine of A minus B, which are in the formula book. However, I glossed through the substitution, didn't I? I did it purposely. There's somebody, yeah. So, somebody is saying there that 6 is half of 3. So maybe I could use double angle formula. But you could use double angle formula even if it is cos or sine. How? Let's see. Yeah. Oh, yeah. That's true. Okay. So, what is sine to a formula? 2 times 2 sine 3x cos 3x times cos 3x dx. Can I write like that? Sine 2a is 2 sine a cos a. Sine 6a is, similarly, sine 2a is 2 sine a cos a. Sine 4 is 4 sine a cos a. No! The number 2, the sine, the cos do not change. It's only the angle that changes. 1 to 2, 2 to 4, 4 to 8, 3 to 6, like that. So, this is 4 integral cos squared 3x sine 3x dx. Now, do you recognize something? When can you use substitution? When you have a function and its derivative. I have a cos 3x. When you differentiate cos 3x, I get sine 3x. What do I get? I get minus 3 sine 3x. So, can I write as minus 4 over 3 integral cos 3x the whole squared times minus 3 sine 3x dx. U squared du. So, it is minus 4 over 3 cos 3x the whole cube over 3. So, which is minus 4 over 9 cos cube 3x plus c. Which is completely different from the answer I got before, but trigonometric identities you can use to show that this would be the same as the other one. Yeah? Tricks and tricks and tricks and tricks. So, I have done Q. Let me do R before I stop. Right. Evaluate integral 0 to pi over 3 sine power 4 theta d theta. Can't integrate directly. Can't, in this case, definitely can't use substitution. It's not a fraction. It's an even power of sine. The moment you have an even power, double angle formula. So write this as integral 0 to pi over 3 sine squared theta whole squared d theta. Okay. Cos 2a equal to 1 minus 2 sine squared a. So sine squared theta is half of 1 minus cos 2 theta. So it becomes integral 0 to pi over 3 a quarter times 1 minus cos 2 theta the whole square d theta. I can remove quarter as LCM. Remember, I can't integrate yet because there's a whole square and there's no derivative of cos 2 theta outside. So open the brackets. So I get 1 minus 2 cos 2 theta plus cos square 2 theta d theta. I can integrate that. I can integrate that. I can't integrate that. Remember I talked to you about the doctor's surgery when I was young. You have a doctor and a small window. In the next room there is a compounder. The doctor writes the prescription, the compounder mixes and gives, and you keep on taking that mixture till either you die or you're cured. In maths, I am both the doctor and the compounder, but I will not allow my patient to die. So I need to get rid of the cos squared. So I'll write it as quarter integral 1 minus 2 cos 2 theta. Using the same logic, cos 2a equal to 2 cos squared a minus 1. Cos squared 2 theta will be a half of cos 4 theta plus 1. Half and 1 is half. Half plus 1 is 1.5. So quarter integral 3 over 2 minus 2 cos 2 theta plus half cos 4 theta d theta. Don't have to simplify, so that's quarter times 3 theta over 2 minus cos 2 theta gives you sin 2 theta over 2, the 2 cancels, minus sin 2 theta plus 1/8 sin 4 theta plus, between the limits 0, let's make it pi over 4. 0 and pi over 4. Let me change it to pi over 4, pi over 4, pi over 4. I forgot to write the limits here, doesn't matter. Right. So now I don't get roots and cubes. You can get nothing wrong, but I would prefer using this to make life easier. So it's a quarter times 3 over 2 times pi over 4 minus sine pi over 2 plus 8 sine pi minus 0. So that is 3 pi over 16, 3 pi over 8 and 3 pi over 32. 3 pi over 32 minus sine 90 is 1. So quarter plus 0. So that is 1 over 32 times 3 pi minus 8. That would be the answer. I'll stop at that stage. I will take up more questions next time. So I have done up to R. Okay. I've done up to R. I think I'll take up STUVW later. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded and launched. Thank you very much.